Hello friends, today we will be dealing with the topic complex numbers. As you are aware, numbers is what we use while counting or doing any mathematical operations. So you may have come across different types of numbers. So just think about that. What would be the different types of numbers we have come across? You may list out real numbers, then it would be natural numbers, whole numbers, integers, rational, irrational. In this way, the list may continue. You may also come across imaginary numbers. As you all know, when you take the square root of a negative number, it gives us a imaginary number. We take the square root of -4. So how do we go about this? We define a unit number, which is I is equal to square root of -1. So this would be then written as which would be plus or minus 2i. So in this way, I is equal to -1 helps you to go about solving a numerical at the square root of a negative number. So imaginary number defined as I is equal to square root of -1. So we can go further for I square I cube, which is nothing but I square would be -1. How would you go about solving I cube? It would be I square dot I. So that would give you minus I. In this way, I calculate the n powers of I. So this is with respect to imaginary number. Now what does complex number? How does complex number come into picture? Complex number is nothing but a combination of real and imaginary number. So it has a real part and an imaginary part. And how we represent? We represent it as z, which is equal to x plus iy. So the real part of z is x, imaginary part of z is y. So x plus iy is called the Cartesian form of complex number. You can also go into writing the polar form, which will come across later. But here, complex number is a combination of real and imaginary. And the real part is x, and imaginary part is y. Now, just as for real numbers, we have basic mathematical operations like addition, subtraction, multiplication, division. The same operations can be performed on the complex number. So let's go about applying those operations for the complex number. The first operation is addition, then comes subtraction, multiplication, and division. Now, as you know, z is equal to x plus iy, the Cartesian form of the complex number. So, if you have two complex numbers z1, which is equal to x1 plus iy1, and z2, x2 plus iy2, you have to perform addition, z1 plus z2. How you go about this? You have to add the real parts of both z1 and z2 together, and the imaginary parts of z1 and z2. So add the real parts of each of the complex number together. Similarly, add the imaginary parts of each of the complex number together. So if you take the example of z1 plus z2 will be 3 plus 5i plus 7 plus 2i. The answer would be add the real parts. So 3 and 7 would get added, give you 10, and 5 and 2 added, give you. So addition of two complex numbers will give you a complex number. Even a real number 0, or suppose you get a real number 8, it may also be written in the complex form as 8 plus 0 I, where the imaginary part would be 0. So it's not necessary, but we can, even if you get just the real part and imaginary part is 0, we can call it as a complex number where the imaginary part is 0. So any real number is a complex number with imaginary part to be 0. So when you go for the subtraction operation, it goes in similar way. You just have to subtract the real parts together and the imaginary parts together. So instead of plus, this will be minus, this will be minus. You are performing the subtraction operation. Now what about going for multiplication? So now you have two complex numbers z1 and z2 again to be multiplied. So it will be x1 plus iy1, x2 plus iy2. So aim is to multiply the two complex numbers. How it goes about, you have to multiply each real part or each part of the complex number with the other parts of the complex number. So x1 would be multiplied by this second, that is z2, and iy1 would be multiplied by. So in similar way, how we perform multiplication operation with the real numbers. So you get x1 x2 plus I y2 x1 plus I y1 x2 plus I square y1 y2. Now you know I square is nothing but minus 1. Then club these terms together. So you get x1 x2 minus y1 y2 plus, and take I common. You get y2 x1 plus y1 x2. So this gives you z1 into z2. Then to go about division. Here you have now x1 plus i1, x2 plus i1. Now this operation differs from the operation of division performed on the real numbers. How is it? For real numbers, if you have 5 divided by 8, you can perform it easily, no modification required. Whereas here, first you have to go for modification, that is to convert the denominator of z1 by z2 to a real number. So how do we go about converting this denominator into a real number? That is by multiplying by the conjugate of the complex number. Now what does conjugate of a complex number mean? If z is x plus iy, the conjugate of the complex number z bar would be x minus iy. So what you have to take is the negative of the imaginary part. So x remains as x, you had y, which is converted to now minus y. More probably you can write as x into this. Z bar is the symbol denoted for conjugate. So when you multiply the conjugates with each other, what you get, you can see, you have x plus iy x minus I1. So it's similar, applying the formula a plus b into a minus b gives you a square minus b square. Similarly, instead of a you have x, so that would become x square. A square minus b square, so minus sign would come, and instead of b what you have is I1. So it would be I square y square. So what would z bar become then? It would be x square. You know I square is nothing but minus 1. So that would give you x square plus y square. So same thing, we go for division and multiplication of z1 by z2 with the conjugate of the denominator. So let's take an example and solve the problem. I feel multiplication, addition and subtraction will be clear to all of them. Division, little bit to understand. It differs from the real operation. Suppose I have 3 plus 5i upon 2 plus 7i. So now aim is to convert the denominator into a real part. So I am multiplying by the conjugate. Now what's the conjugate of 2 plus 7i? It's 2 minus 7i. So since I am multiplying the denominator, I have to multiply the numerator also, so that the value doesn't change on the LHS. So now here you have to perform the multiplication operation. It's 3 into 2, 6 minus 21i plus 10i minus 35i square. And for the denominator, you know z into z bar is nothing but x square plus y square. Similarly, this would be 4 plus 49. So overall it gives I square is nothing but minus 1. 35 plus 6, 41 minus 11i upon 53 is z1 by z2. And what we have got is a complex number. The only thing is understand how to get the conjugate. If it would z hat would be x minus iy, and the conjugate would be x plus iy. You have to take the opposite sign of the imaginary part. Do not play with the real part of the complex number. If it would have been minus x plus iy, then the conjugate would be minus x minus iy. Minus remains the real part. There is no sign change with the real. So understand this and then how is it denoted. So z into z bar would be x square plus y square. This you will be using it most of the times. Just remember how to play with the conjugate and solve the division sum. So let's revise it. Different numbers which you have encountered. What do you mean by imaginary number? It's nothing but a square root of a negative number, and the unit imaginary number is nothing but I, which is denoted as square root of minus 1. So then you can calculate the different powers of I square, I cube, and so on. Complex numbers, what are those? It's a combination of real and imaginary numbers. So you have a real part and an imaginary part. And what are the different operations? The same operation we perform in the real number are performed on the complex number. Addition, subtraction, multiplication, more or less similar. The only thing is division. How it should we make use of the conjugate to convert the denominator into a real number and then solve the problem. So I would suggest, so I'll take some different examples on your own or from the notes and try to solve the problems related to addition, subtraction, multiplication. Now let's understand why we have understood what is complex number. But what is the importance of studying a complex number? Now it depends on the branch in which you are studying, but most of the times we encounter the square root of imaginary numbers while deriving a theorem or applying a theorem to a particular problem. So in that way, to develop the theories, etc. Complex numbers have helped most of the times. Like in electrical circuits, you may have come across complex numbers most of the times, where you make use of the polar form, which you will come across later, the phase angle theta, phase lag. So complex numbers have played an important role, and it's because only of the complex numbers that we may have been able to apply, derive different theorems or proofs for the statements that has been hypothesized. So understand the theories of complex numbers and later the complex function becomes important. From the gate point of view, generally it has been more or less 2 to 3 questions, but on an average 2 questions you can expect from complex numbers. So even the topic within the complex numbers is not so vast. Basic operations with respect to complex numbers, then the De Moivre's theorem applications, and going further would be the complex functions. That is, just we have limits, continuity, and derivatives and integration for the real functions. Similarly, for the applied to the complex functions. So more or less, to be able to solve 2 questions, 2 to 3 questions normally, not much, on an average 2, and at times also 1. It depends, it may be for a 1 mark question or a 2 mark question, depending on the type of sum. If you go for complex functions, maybe it may be of 2 marks. With respect to complex numbers, it would be of 1 mark. So it's important not only from the gate point of view, but also when you are trying to go for a research work or applying different theorems, you may come across these complex numbers and functions. So overall, it's an important topic and also not so difficult to understand, easy to score. So let's concentrate on it further and move about solving more problems as well as the theory concept.